If I have another line beside it, and it is never crossing, that's a horrible picture. It's never going to cross it. They go on forever in both directions. But in order for it to never cross, what cannot be happening? Can they have slightly different slopes? No. If they had slightly different, they would just cross a long time down the road, wouldn't they? Because maybe one would kind of veer in a little bit. But to prevent that from, see, mine are definitely not looking so hot. It looks like they're going to meet down the road, doesn't it? But really what I'm trying to draw and illustrate for you, like we see in the architecture in this room, our lines are done correctly where that spacing never changes. The slope has to match exactly to guarantee the space between the lines is the same always. Because that's the only way for them not to cross. You see how the definitions build on each other? Consistent slope for a line, never going to cross so the space can't be different. Well, that means they have to have the same slope. That's where this conceptual stuff leads you. So same slope. That's the big deal thing that you got from perpendicular last class. And what's the symbol? If I were going to abbreviate it symbolically, how can I represent slope, parallel? Well, okay, if I wanted to use the M, and M does mean slope, but these two little lines like this, that means parallel slope. Good. Very well done. Okay. Perpendicular. Talk to me about perpendicular. It's kind of the opposite of parallel, isn't it? They don't always cross, but they do cross in a very special way. Talk to me about the way they cross. 90 degrees. So it like makes a T or an X, right? It's a very specific kind of crossing. When you look at it, if you saw the picture of it, let's say this were one of the lines. Doop-de-doop. That might be the other line. They cross to make a T. And in fact, if you saw a picture, they'll usually put a box in the corner to show you how perfectly. To show you there's exactly a 90-degree angle. These things are very nicely coming at a corner. The exact opposite idea of the parallel, where they never cross, is the perpendicular, where one of those lines goes from going one way to turning itself around and crossing exactly well into the other one. In the room you see it. You see corners in the room, don't you? Or on the ceiling, you see perpendicular lines. Where the tiles are coming together. You see T's or X's, however you want to look at it. They're perpendicular. I mean, if they didn't cross exactly right, you'd have a really ugly ceiling because you'd have, you know, can you imagine? Like if you were laying tile in your house, the mess you could make if you don't make it exactly right at the corners. Yeah. That's going to be what happens to me, I think. I have a project coming up. So it's going to not be perpendicular. It's going to look kind of bad. That's okay. We'll see. I'll tell you guys how it goes. So the idea, though, is this is the exact opposite idea of parallel. So where parallel means the same slope, perpendicular is the opposite slope. Huh. Opposite. Opposite slope. Okay, that sounds super redundant and doesn't mean much yet. What do I mean? What is going to take the direction of this slope? Let's say it's going downhill. If it's already going downhill, what's the opposite of downhill? Huh. So what's going to take a slope and turn it around so it can run exactly smack into the other one? Doing what to the slope? Positive or negative, right? Putting a negative. Negate the thing. Turn it around. We know that positive or negative in front of it is what makes it go up or downhill, isn't it? Okay? So the first opposite says, hey, put negative in front. So another way of saying this is the negative, and to turn it around quantitatively, the other opposite is the reciprocal. It's the negative reciprocal. You flip the fraction, you stick a negative in front. That's, I think, what you guys were trying to say. The negative reciprocal. Remember, that just means flip it and put a negative in front. As far as notation goes, what does a perpendicular slope look like? M with a sub what? Did you guys get this in the symbol last time? It's M. It's like you put a little upside down T there beside it. So if you ever see someone writing, that symbol right there means perpendicular. Perpendicular slope, parallel slope. But the main idea, even though I'm showing you kind of like little short, ways to write it fast, opposite, that, and same slope. Those are the most two important things that you would have learned last time, or at least been exposed to briefly last time. The reason this is so important is because basically if you got the section I just reviewed with you, 4.5, as long as you know what the definition of these is, that it didn't change anything. You have nothing harder to do. Let me show you an example. And I'll use it off the worksheet since I know that's what you guys have been working on, that's what you want to see. So for example, okay. This just has you say, are they parallel or not? So we'll do a couple of these and then we'll play with it a little more. Okay. So for example, if I asked you, are these parallel or perpendicular? I'm going to change the directions of the worksheet just a little to save us time. Okay, so we have y equals 2x minus 5, and we have y equals, so we're talking about the relationship of these two lines, negative 1/2 x minus 5. What's the important thing I'm looking at? Which one's the slope, my negative 5 or my 1/2 and 2? Okay. Slope, remember again, then you guys said it right, is the number in front of x. So that's what you're looking at. These are your slopes. Talk to me, guys. They're not the same, so they're clearly not parallel. Anything else? Oh. One, they're opposite signs. One is negative, and the other is positive. And they're flips of each other, aren't they? If you took the 2 and put a 1 underneath it and flip it, you get a 1/2. A negative 1/2. So they're not parallel. What are they? Perpendicular. They're perpendicular. Do we care anything about that negative 5 on the end? So I could have had numbers that didn't match. I mean, I could have had, let's see if she has one on here. I'm sure she does. I could have numbers like this. So let's look between these two lines and talk about it, and then we'll compare that y-intercept a little bit more. So we have that right there, right? Again, the slopes are negative 1/3, negative 1/3. This time, what do you have? Parallel. Oh, but wait a second, guys. In this example, these do not match. Is that okay? Yeah, again, it doesn't matter when it starts. All you care about are how the slopes compare. That's the only important thing. Okay? Only thing you care about are the slopes. Tell you anything about the slope right now? No, this is not in the right form, is it? They tried to trick us, didn't they? They put it in general form, which is fine and dandy for later on in math, if I actually wanted x and y together. But the form that we like so well is y equals mx plus b, because you can pull that slope straight off of it. It's not in that form, guys. It's tempting to look and say, oh, look, there's 3 in front of those x's, but there's not. That's not the slope. To get the slope, what do you have to do for each of those equations? Get y by itself. Get it in the form that we're comfortable with. Okay, that's going to make me lose my mind. So, let's do it. Let's see, I'm going to minus 3x, because I'm going to write it the way I taught you guys. I forget sometimes. So the 3x, I have decided to move over to the other side. I'm trying to get y by itself, correct? So I'm going to move 3x over by saying minus 3x. I get negative 2y is equal to 5 minus 3x. With me? I want y by itself. What do I do? Divide everything by negative 2, right? Everything on both sides. So that means I had to put that line under both pieces, because really now I have y equals 5 over 2 minus 3 over 2x. What's my slope? I'm going to highlight the slope since that's the whole thing we actually care about. What is it? The stuff in front of x, right? Slope is always the stuff in front of x because we know that y equals mx plus b. We are interested in this, in the slope part. So we're looking for where is that x so I know which one's the slope. The only time we can just take the number off the x, though, is when y is by itself on one side. When it's in y equals mx plus b form. That's really important. So what is the slope on this line up here? Negative 3y. Okay, go ahead and solve for the other one. Let's get y by itself on the other line so we can compare their slopes. And again, I write it in a way that I didn't teach you guys. When you move it over, it becomes negative 3x. So you get 2y is equal to negative 3 minus 3x. You divide by 2 everywhere, correct? I see an expression. Are we okay? Do it. Oh, I made a mistake, didn't I? You're right, that is a negative 2. That would make that positive and that negative, wouldn't it? Big deal. I'm so glad you caught that, Kel. Absolutely. Yeah. Did you guys see what he just asked? You are dividing by the same thing on both sides. I didn't mean to have that typo in there. And that makes a difference because we're about to give it the wrong answer based on that difference. So it's very good to be careful like that. No. On the test, you would have gotten credit though. Okay. Now, look at the two slopes. Are they perpendicular or parallel? Be careful. It's a trick question. To be parallel, they must be exactly the same, which they're not. To be perpendicular, they are opposite, aren't they? Negative reciprocal. We've got the negative thing going on. Positive and negative. But is one of these the flipped version of the other? No. They're not opposite. It's only partially opposite. Has to be opposite. Negative reciprocal. So it doesn't pass. Is it okay? Is it okay to not have them be parallel or perpendicular? Sure. It means maybe they cross, but just not exactly at a 90-degree angle.
So again, why it's not parallel?
Well, it's not parallel because parallel lines have the exact same slope. It's not perpendicular because perpendicular is opposite. We have opposite signs. We don't have upside-down numbers from each other. It's neither. I mean, you can have, yes, you can have lines that cross that are perpendicular. Look at that. Check it out. Look, they cross. Are they perpendicular or parallel? No. Okay. That's not the graph of these two. I'm too lazy to do that. But what I'm trying to emphasize is, yeah, it's okay to be neither. That's what I'm trying to emphasize. And if you wanted to graph it and see what this specific one looks like, you could do that. I just don't want to do that. It's neither parallel or perpendicular.